Hey guys, welcome to another video. So in today's video we have another analytical problem. So it says in the diagram below they give us coordinates A, B, C and D, and they say these coordinates are the vertices of some quadrilateral. So we don't know what kind of quadrilateral this is. It could be a square, it could be a parallelogram, it could be a rhombus. So the first question says calculate the length of BD. So in order for us to calculate this length, we need to use the distance formula. So distance BD is equals to XD minus XB squared plus YD minus YB squared. So I've just written XD and YD and XB and YB here to make substitution easier into the formula. So this is equals to XD, which is 0, minus negative 2 the whole squared plus YD is 1 minus YB the whole squared. So this is equal to the square root of 2 squared plus negative 6 squared, and this is equals to square root of 4 plus 36, which is equals to the square root of 40. But the square root of 40 can be seen as square root of 4 times 10, which is equals to 2 square root of 10 units. So the next question says show that AC is equals to BD. So they want us to show that these two lines are equal in length. So already we have the length of BD to be 2 root 10. So we just need to calculate the length of AC using the distance formula. So once again we can apply the distance formula. We can say the length of AC is equals to square root of XC minus XA the whole squared plus YC minus YA the whole squared. So now we can just substitute. So XC in the given case is minus 4 minus XA is 2 the whole squared plus YC is 3 minus YA is 5 the whole squared, and this is equals to the square root of negative 4 minus negative 2, that is minus 6 the whole squared, plus 3 minus 2 is negative 2 the whole squared. So this is equals to square root of 36 plus 4, which is equals to the square root of 40, which is equals to 2 root 10 units. So therefore AC is equals to BD, and therefore the diagonals are equal. So moving on to the next question, they say that we need to show that the coordinates of M, the midpoint of BD, are minus 1 and 4. So let's consider the line BD, and we should know M here is the midpoint. So to find the coordinates of M, we need to apply the midpoint formula. So M, which is the midpoint of line segment BD, is equals to XD plus XB over 2 and YD plus YB over 2. So now we can just substitute the coordinates respectively. So XD is 0 plus XB minus 2 over 2, and YD is 1 plus YB is 7 over 2. So this is equals to negative 1 and 4. Then we can see on our schematic that X is negative 1 here and 4 there. So we can accept these coordinates. So the next question says calculate the gradient of AM. So they want us to calculate the gradient for this line here. So we need to apply the gradient formula. So notation is very important. Small letter m, am, gradient of am is equals to change in y, which is ym minus ya, over change in x, which is xm minus xa. So now we can just substitute. Ym is 4 minus 5 all over xm is minus 1 or negative 1 minus 2. So this is equals to negative 1 over negative 3, which is equals to 1/3. And we can see that am has a positive slope, so we can accept this gradient because it's positive. So the next question says prove that am is perpendicular to BD. So we need to prove that am and BD are perpendicular. That is the angle that forms between the two lines is 90 degrees. In order for us to prove that those two line segments are perpendicular, we need to show that the product of their gradients is equals to -1. So we've already found the gradient of am to be 1/3. So we need to find the gradient of BD. So once again, we can apply the gradient formula. Small letter gradient of BD is equals to change in y, yb minus yd all over xb minus xd is equals to yb is 7 minus 1 all over xb minus 2 minus xd 0. So this is equals to 7 minus 1 is 6 and -2 minus 0 is -2. So this is equals to -3. So let's test to see if the product of their gradients give us -1. That is m multiplied by mbd. So mam is 1/3 multiplied by -3, which gives us -1. So therefore am is perpendicular to BD. And so the last question says, write down given reasons what type of quadrilateral ABCD is. So firstly, we saw that the length of the diagonals are equal in length. So this is the first property of a square. And we also learned that the diagonals bisect at 90 degrees. So that is the second property of the diagonals of a square. So we can say that ABCD is a square because the properties of its diagonals hold. The diagonals are equal in length and they bisect at 90 degrees. The first condition doesn't hold true for a rhombus and a parallelogram. Therefore, we accept this quadrilateral to be a square.